Howdy, my name is Alex Thompson, and today I'm going to talk to you about how exposure to PFAS increases bee mortality, decreases hive maintenance, and is present in 92% of honey. So let's address the question probably on your mind, what are PFAS? PFAS, that is an acronym that stands for per and polyfluoroalkyl substances. If you've ever heard of forever chemicals, that is PFAS. It's a group of about 4,000-ish chemicals that we know of, but they all share the same basic structure, and so they're grouped together. That basic structure is shown here in figure 1. If you've ever taken organic chemistry, so this right here, these branches, that represents carbon, and you have these carbon-fluorine bonds. And these bonds are very famous in organic chemistry. They're the strongest bonds that we know of. They're very difficult to break, and as you can see, there's a whole chain of them. And so PFAS are very persistent and they're hard to remove from ecosystems. They have a tendency to kind of accumulate and stay within biospheres. And that's not good because they've been linked to cancers and immune system damage in people. Okay, now that I've nerded out about PFAS enough, let's talk about honeybees. You can see a honeybee there to the right in figure 2. This little girlie, her scientific name is Apis mellifera. She is very important for pollination in both agriculture and native plants. Apis mellifera can be exposed to pesticides when they're foraging, and this pesticide residue has been linked to health issues and colony failure. So let's link these two topics together. How do PFAS impact Apis mellifera? So this question was investigated by an Australian university in 2021. They had 7 groups of bees, each with 1,000 bees, and they exposed each group to a varying level of PFAS over the course of 4 weeks. So they had, as you can see, this is one group, this is one group. They're each separated by these screens. And the method of exposure, they had this sugar water here. Each group had a different PFAS concentration in them. And what they found was that with increasing PFAS exposure, the bees showed increased mortality, decreased brood development completely, and showed a decrease in gut health. So let's look at some data to really visualize what this study found. So here in figure 4, they have, this is the number of young adults that developed from the larva stage, and this is our concentration. And as you can see, this is what I find to be most significant. With all tested levels of PFAS concentration, there are no larvae that develop into young adults. You only have the control group that had any young adults. And here you have the PFAS concentration again. This is the number of larvae that were produced. So in a couple of these experiments, you did have some larvae, but they did not survive into adulthood. And here you have the worker bee mortality. So this is the fully developed bees that were at the start of the experiment. And as you can see, up to 60% of the population did die. And that is not good. So now let's look into the behavior of these colonies that was observed. So as you can see here in figure 6, as PFAS concentration increased, there was a decrease in the average hive temperature. And this can be indicative that the hive had trouble maintaining a homeostasis within the hive. It was also observed that there was a decrease in hive maintenance. That's things like fecal matter and dead bees being removed from the hive and cleaned. The hive should be relatively clean. There was also a decrease in pest control, which I find very interesting because there was observed increases in agitation and defensive behaviors. So now let's look at honey. A study from a different university studied 16 different samples from 7 different countries within the EU, within different regions of Europe. And as you can see from this figure, pretty much all of them, minus a couple here, did show PFAS presence. And this is significant because if PFAS is present in honey, it can be reasonably assumed that these honeybees are being exposed to PFAS. So, in short, what did I just talk about? So, we know that PFAS exposure does largely impact Apis mellifera, even at small concentrations. It has been shown that hive mortality greatly increased and brood development completely stops at all levels of exposure. We also see that exposure increased agitation levels and decreased hive temperature, maintenance, and pest control. And from a little bit of thinking, I do believe this might be an effect of the significant decrease in population, as there would be less worker bees to maintain the hive temperature and fight off pests. And also, we've seen that PFAS has been found in local honey originating from 7 different countries. So, the significance. Why do we care? Why is this important? So, PFAS exposure is an international issue. PFAS has been shown to be present all over the globe, and now we have seen that it does specifically and greatly harm honeybee populations. More research is needed to be done on PFAS and Apis mellifera to link these two subjects. PFAS is a relatively understudied and new research field. I had a little bit of trouble specifically linking PFAS with Apis mellifera. More research needs to be done to study why these bee populations are being harmed. And as PFAS has been shown to have presence in honey, it might be necessary in the future to find a way to remove PFAS from honey before human consumption, as it has been shown to be harmful to humans. Lastly, thanks and gigum.